Good morning, everyone. Um, Welcome to Unlocking Effective Teaching Strategies. Um, I am Christopher Evans. I will be your host for today's webinar. I was in education for about 18 years and have taught computer science for the last 10 of that, using CodeHS in my classroom for most of that time. So I'm excited to be a part of the company now. And with me today is Robin. She'll be fielding questions and whatnot in the chat. So I will let Robin introduce herself.
Hi, everyone. Thanks for stopping in to learn about some more teaching strategies. Never hurts to have a couple extra in your back pocket. I was a high school teacher for 15 years up in Northwest Indiana, and I used CodeHS in my classroom, and now I work for CodeHS. So super excited to be here with everyone.
All right, and if anyone is in Texas like me, I hope you are safe and not in the path of the storm. We're benefiting from it up here in Dallas of just getting some much needed rain, but it is gnarly in other places. So be safe out there. Basic agenda for today. We're gonna do intros and agenda and whatnot. And if you would in the chat, put where you're from, and so we have an idea of where everybody is joining us from. So just pop in and say hi and where you're located. The teaching strategies that we're going to cover are going to be collaboration, debugging, and differentiation. These are just a snapshot of the wealth of ways that you can integrate our platform and these teaching strategies into your classroom. We only have an hour, so we're only going to touch on a few of them, but we have a lot of resources available for other teaching strategies as well. If you'd like to access a copy of the slides, the link is on the screen, and Robin will drop that into the chat as well, so you can have a copy of today's slides. Wrong way. If you have any questions, you can drop them in the Q&A down at the bottom, or put them in the chat, and we will address those as we are able. You will need a CodeHS account to get credit for today's webinar and to participate in the activity. So if you go to codehs.com/sign up, if you don't already have an account, and you can create a free account, it takes 30 seconds, if that, and you can join us in all of the festivities. The link to the certificate of completion. Again, you must be logged into your CodeHS account to access this link and get credit for attendance today. Your certificate will be emailed out to you later this week. Could be as early as this afternoon, but later this week. If you are not familiar with our product, CodeHS is a comprehensive platform for teaching computer science in elementary, middle, and high schools. We have a full K-12 curriculum. It is completely web-based. We offer online and offline professional development, and a full toolbox of resources and tools for teachers to assist with the teaching computer science in their classrooms. The platform has instant feedback. As soon as the student submits something, you can see it, you can give feedback and send it right back to them. There are time tracking tools. There are grade tracking tools. We provide a mountain of different ways to help manage your classroom, and everything is web-based. Excuse me, there's no software to install, and you and your students can access our platform anywhere that they have an internet connection. So the first teaching strategy that we're going to look at today is collaboration. Collaboration in computer science is key. I would always tell my students, computer science is not a solo activity. When they get into the profession, if that's where they decide to do, they're going to work on a team and they're going to collaborate. And so that's why I explain the importance of clean code and the importance of good comments and things, so that when the rest of their team works on code that they wrote, they understand what it means, because they're not going to be the only one looking at it. So, collaboration in computer science, again, it's more than one person is working together on the same project. The goal is to make things happen more quickly, and work smarter, not harder, by dividing up the work. A lot of times troubleshooting is done collaboratively. Even in our company, we have a team that, as problems come in, they get assigned to whomever is appropriate to answer that question and troubleshoot that problem. And we all work collectively toward the same goal. Coding, I mean, there's times where you're going to work on your own independent projects, but coding should not always be done in isolation. The students should work together. They should share ideas. They should share their issues, because all of us is smarter than one of us. So make use of the resources that you have with your peers and other people in the room. When you use collaboration, students are forced to look at code from a different perspective, because they are looking at code they didn't write. It's the adage of you're too close to the problem. So you may have trouble seeing the issue because you're too close to it. When you work on something you haven't written, you have a different perspective, and you're able to bring that perspective to that problem and find a solution that maybe the author of the code was unable to find. Collaboration encourages listening skills, critical thinking skills, patience, and trust amongst the students. And these are all skills that they're going to need in the workforce, whether they go into computer science as a profession or not. These are skills that are important in the workforce that will help them out once they get out of school. And it'll even help them in their other classes. I tell my students all the time, you may not be a computer scientist, and this may not be what you're into, and you're taking this because you needed an elective, but you're learning skills that are applicable across the board. The critical thinking skills, the troubleshooting skills, these are ways of looking at a problem in a different way that are useful in all their other classes. And again, once they get into the workforce, these are skills that are going to be very important. And again, more heads are better than one. I said it earlier, none of it, all of us is smarter than one of us. So real programmers do collaborate. I bring that up. I brought that up in my classes all the time, that this is not a solo effort. You're going to be working on a team, and it takes a village, and it is important for that village to get along and work together. So real programmers do collaborate. So we're going to look at a quick collaboration feature that we have. It is called the sandbox. It is an area of the platform where you can create a program from scratch, and it's really useful for demoing a concept with your students. So if you're on the CodeHS platform, this is the main dashboard. Up in the top left, I'm going to click on Sandbox, and I'm going to give my sandbox, can't type today, a name. Then I'm going to choose the programming language. We have our main programming languages here that we have content for, Java, JavaScript, Python. We have some HTML content as well. Then we get into programming languages that we really don't even teach on our platform, but are still available to create sandboxes in. So I'm going to create a Python sandbox, and I have my Python sandbox right here. I'm going to click share. Then I'm going to click collaborate and enable collaboration. And I'm going to drop this link into the chat. If I can figure out how to get back to the chat. There we go. I'm going to drop this link into the chat. And if you will follow this link, you will be able to get to our collaborative sandbox. And now I can see that Robin is in, and I can add a new print line here. And I have made an error on my print line. So Robin can jump in and correct the issue that I've made. And now our program runs. And this works just if you're familiar with the collaboration tools, and I sent that to just, let me send that to everyone this time. I apologize. If you're familiar with the way the collaboration works in the Google Suite, it works just like that. There we go. There's everybody popping in. And yes, students can collaborate on an assignment. You will share this link, and that link now becomes shareable, and whomever's in it whoever has that link can collaborate. And you can also assign a sandbox as part of the course, and they can collaborate on it that way as well. So again, this works just like the Google products do. It's in real time. You can see everyone here that is in the platform, and when they're typing, it will show you who is typing and whatnot. And this is a really good way of working in getting the class involved in a coding assignment. When you hit share, Kim, when you hit share and you hit assign here, you can give it a description, and then you can assign it as either an example or an exercise. An exercise will be something that the students can will actually solve and get graded on. An example is just a working example of whatever you're working on, and then you choose the course that you want to drop it into and hit assign, and then it assigned it to that course. And now I can see it in that course right here. This example was added at the very bottom, and then I can move it around wherever I need to. So as far as selecting the students that can collaborate, I don't think we have it where you can actually say these students work together, these students work together. That would be done, you would assign it to them, and then they would have to initiate the collaboration on their end. But you can only collaborate if you have the code. So you can't the link. So you don't necessarily have to worry about people sneaking in uninvited. They have to have the link to get into the collaborative section, into the collaborative activity. So, and I just walked through that. And again, this is kind of a graphical representation of what that looks like. And you can see how where the example here is two different screens, and they're both showing the same code on each screen. So, and this is again just walking you through the way that I did all that. So,
Chris,
yes,
I just want to step in for a second. If you have Pro, you could assign to specific students an exercise. It would be a little bit cumbersome, I guess, maybe to make a sandbox program for each pair of students and then put that in and then assign it to those specific pairs. But if you have Pro and you really wanted to do that, that is something that you could finagle. Yes. Cool. Thanks, Chris.
thank you. So some things to remember: only the project owner can save changes to the program. So the real-time collaboration, the owner would need to save those changes. if the owner of the program is not actively on the program, you no longer have access. So when I close out of our sandbox here, everyone just lost access to it because I'm the owner and I invited you all in and I just closed it. So that is no longer an active collaboration and the link is no longer valid. Even if I reopen that, I would have to give you a new link to start a new collaborative session. That's another way to keep too many people's hands in the pot. If a student creates a sandbox program, they they can collaborate on it the same way, but you have access to that. So if you're concerned about them doing something underhanded or whatnot, you have access to that when you go to your students sections. When you go to your sections and you pull up your roster, you can see every student sandbox and you can get into every sandbox program that your students create. And you can monitor that. A newer feature that we have just introduced is assignment collaboration. It is still in beta right now, and will probably and should be coming out of beta at the beginning of the 24 school year. Individual assignments can be collaborative. It doesn't have to be a sandbox assignment. You can do it on individual assignments and create. So you can in the past, what you would have had to do is if there was an exercise that you wanted to work on as a group collaboratively, you would have had to move that and create a sandbox for it. Now you can work on it directly inside the uh the student's activity. So you would you would go to our real-time dashboard and you can see what your students are working on in real time. And when you select on that assignment, it will open it up and and you are collaborating with them and you are able to help them out in real time. So one thing I will note, we discovered that the collaboration turns off the code history. They are working on correcting that. But the collaboration feature does disable the code history. So, and you have to turn on the collaboration for that particular assignment. It's not on by default. So that the real time, the code history is always on. If you turn on collaboration, it will turn off the code history, but they're working on that. So the next technique that we're going to look at is debugging, which is basically just the process of figuring out what's wrong with your program. A bug is just a problem in the code. Bugs are named literally after a bug. It had a moth had flown into the computer and broke it, and the term bug was coined. You don't plan on writing bugs. But it happens. It's just like writing anything else. We make grammatical errors. We make all kinds of errors when we're writing something. The same thing exists in code. And that's why we have to find the why it's important to teach students how to troubleshoot and find issues in their code. Programming is a trial and error process at times, especially when they're learning new concepts and they're trying to get the syntax and everything right. That it is, I'm going to write this code. I'm going to try it. It didn't work, so I'm going to try it again. Yes, it worked, so I'm going to add to it. We We don't code the entire program all at one time. We code in snippets so that we know where our problems are, because otherwise, if you write the entire thing and then you test it and there's an error, it's going to be really hard to find it. So, this is a fundamental skill for programmers. This will be something that they will be faced if they are professional coders and programmers in their job, and they are going to write buggy code. And this allows them to find those errors and hopefully not make them again. But we all make the same mistakes over and over again. So knowing how to fix them is the skill that we're really trying to implore on these students. And as I said before, this is a skill that is not necessarily applicable to just computer science. This is a problem-solving skill that is useful in other classes that the students will be taking and in the workforce and just life in general. So the mindset for debugging is to have a growth mindset instead of a defeatist mindset and saying, oh, well, this didn't work. Instead of saying this didn't work, it's what can I do to change to make it work and put a positive spin on it. Look at challenges like an opportunity. I have an opportunity to make this work and solve this problem. And they'll get that sense of gratitude and satisfaction in themselves. It allows the students to think creatively and implement the scientific method. I taught my students that the coding and debugging process is very similar to the scientific method. You have a problem, you figure out, you determine what you think the problem is, you test that. If you're not right, then you go back to the beginning, and it's a good cross-curricular concept to show the students is that the scientific method applies not just in your science class. So going a little deeper on the growth mindset, bugs are not bad. They're opportunities to learn. And again, it's about having a positive mindset, not a negative mindset, and that errors and bugs are not because you did something wrong and it's not bad. You just need to correct your misstep. So much like the scientific process, we're going to form a hypothesis. We're going to isolate the problem. We're going to try to reproduce errors, and we're going to take small steps to try to fix them. So in doing so, we're going to observe, make our observation, just like in the scientific method. We're going to, ask questions. Why is it broken? What part is broken? When did it occur? What line is it on? Things like that. Then we're going to figure out how we can address that problem. If the mouse click function is not working, well, let's figure out what we did wrong to make sure that the mouse click function does work. And then we apply the fix and then run the code again. And if it works, it works. If it doesn't, start over, because this is a cyclical process. Pseudocode is a useful way of debugging. It writes the program out in plain English, and I really like pseudocode, especially for earlier programmers and my younger students, because it forces them to write out what the program should do and how it should do it without focusing on syntax and not getting hung up on syntax. And pseudocode is a good way of planning your programs, and then when you run into an issue, you can go back and see into your pseudocode and see where you made the mistake. So an example of pseudocode. So to run the race, we repeat run lap 8 times. To run one lap, we repeat one to run lap. Run one side and turn left 4 times. To run one side while the front is clear, move. These are all commands that we can give our mascot, Carol the dog, in our beginning lessons. It translates to, we are writing the function run race we're now naming our functions. And we still have the pseudocode of what each function should do, but now we're giving the functions a name. Now we're implementing the actual code. And so now we have started with plain English of how it worked, added the names of the functions, added the syntax. So the more complicated the exercise and the program, the more issues the students are going to run into. If you ask them what is it supposed to do in plain English, it can help them narrow down where the errors are. And pseudocode is an excellent planning tool, but it can also be used in the writing process and when you've already, or in the debugging process rather. If you've got one section of code that you know is not working, your students can write the pseudocode of that section and debug it that way and troubleshoot it. Another way of debugging is with diagrams, and this gives the students a visual reference for what the program is supposed to do. So diagram out in a flow chart of what the program is trying to do. Then they can see, is this the best way to solve this problem? Perhaps they've overthought it and they have more steps. And when they see it visually as a flow chart, they can see how many steps it actually is and how much is actually going on. And that gives them the opportunity to perhaps streamline their code, which may be where the error is. So, diagrams are often useful to let to see the students see if they solved the problem or not. If the diagram completes or the flowchart completes, then it shows that they were successful in solving the problem, and now they can go to the code and fix it. So here's an example of diagramming out our solution. Now, in this case, we're not going to use a flowchart. We're actually going to look at our output and see we're going to map it out on the actual assignment. So our goal in this example is to clean up all the tennis balls, but we don't know how big the grid is or where the tennis balls are. So we have to get Carol the dog to clear this entire board. So one way we can do it is a zigzag pattern where Carol goes across the screen up to the next row, down to the next line, and zigzag all the way to the top. So how many functions would this take? What's in the main loop? What are the edge cases? Meaning, what are some conditions that we hadn't thought of that wouldn't work? And is this what's tricky about the solution, and is this a good solution? So there's often more than one way to solve a problem. So this is one example, and you just analyze this to see if that is a good method. We have the back and forth method where Carol goes all the way down and cleans up the tennis balls, then comes back before moving up to the next line. And you kind of ask the same questions. And you can take this diagram and then you can write the pseudocode for it to see how it would map out and things like that. So, our last technique that we're going to look at is differentiation. And we're going to look at how to address every student in your room, whether they are an advanced student that could teach the class, and I've had plenty of those, or they're special needs, or they just need extra work or an extra help. Okay, so what is differentiation? It's just simply the process of identifying student needs and modifying instructional approaches to reach students of different abilities. the main goal is that no matter what the starting point is, all of your students reach the end point together, or at least the same end point. So, how can we differentiate computer science? Well, the easy way is, or an easy first step is to let students do block code. You can give the students the option on several of our assignments to use block code instead of written code. This is an option that you can set in your course settings to allow blocks or not. If you're not familiar with block coding, if you're familiar with Scratch, that's really where the idea comes from. You just take these blocks that are actually code snippets and you stack them, and it gives you a visual of what the program looks like without actually having to physically type out the question, or type out the syntax and the code. It's already done for you. It's just drag and drop. And this is really useful for your English language learners that may not be able to type as well, because the color coding helps out, and it allows them to program while they're still learning the language, the physical language that the programming the program is written in. Diane, block code is not available on every single course. There is a knowledge base article that talks about block coding and lists what the available courses are and the limitations. And if Robin would mind pulling that up and posting that link in the chat, that would be great. That knowledge base article has everything you need about block coding. Thank you, Robin. Another way you can differentiate content is to offer supplemental resources. You can find relevant news articles. There is always something going on. Thanks to Elon Musk and people like that, there's always stuff going on in the computer science world and the technology world that you can have students read up on. You can do offline worksheets. We have a lot of options in our activities and in our lesson plans of handouts. If you're on a pro account, you have access to these handouts and offline materials that students can work on. You can provide graphic organizers to help students with organizing their code and things like that. We also have supplemental challenges and supplemental activities that in the platform that you can include, but anything that you possibly have, if you've taught before and you have exercises that you've used that are useful, you can pull things in if it's an AP class from AP Classroom, things like that. So any way that you can enhance the learning and provide challenges for the advanced students, and any way that you can assist your struggling students is useful. So why would we need to differentiate in a CS classroom? If all of your students are taking this class, and unlike let's say your math or your English, for the most part, everyone comes in on the same level because everyone has taken the same classes coming in, with obvious exceptions. So you don't know anything about that in your students coming into your coding classroom. So some may have different coding backgrounds. Some of them may have taken coding camps on their own, and some may have never coded before. So I've had the full spread in one class before. So it's important to try and modify to address everyone's skill level. Some students may not have, may not be very confident in their coding, and they may be intimidated. Some may be ready to reprogram Facebook. Some may just not care. Um, I had uh, I had students that I had that issue with. They were just dropped in my class or they needed another class and they just didn't care about the content. So that's another student that I have to differentiate my instruction to try to reach. So the principles of differentiated instruction are broken down into content, process, product, and the learning environment. So the content is the knowledge, concepts, and skills students need to know. The process is how they make sense of the content. The product is how the content is delivered. And then the learning environment is the physical space that the students will be in when they're learning. So, some options for the learning space or teaching methods rather, sorry. You can do whole group instruction. You can have that's teacher led. You can have small group that's teacher led. You could have small group that's peer led, or you could have individual work. My classroom tended to start at the top and work its way down. We started with whole group and then the groups got smaller and smaller and smaller until we got down to individualized work. There was a lot of peer tutoring in my classes. The struggling students would help the other ones out, and that's really helpful because they might be more relaxed around their friends and their peers. So letting students troubleshoot and help them out is a good way to differentiate your instruction. So another way to differentiate the product is how is the content presented? Are we using end of unit tests? Are you going to do projects or are you going to do actual multiple choice exams? Are you going to have teams? Is every student going to work by themselves? So there's a bunch of different ways that you can present this product, and our platform actually provides resources for presenting the product in multiple different ways, depending on what suits your students best. Perfect example here of an assessment method is the choice board. Instead of telling the student, every student is going to make this project, you can have the students choose a project within the scope of the course. I am a big fan of choice boards. I ran an entire course based off of a choice board. It wasn't just the project, it was the content itself. So I'm a big fan of choice boards. It gives the students ownership and it really helps with buy-in because the students are getting to choose what they want to do because kids are told what to do all the time. Adults are always telling kids what to do. If you give a student an opportunity to make a decision for themselves and be the facilitator of their own learning, that means more to them than if you said, go do this. Everyone's going to make this project, go. Giving them ownership in their learning goes a long way. And with the choice board, you can differentiate the instruction and the project by letting them choose the area that works for them, and it doesn't single anyone out. One issue that people come across with differentiation is the stigma of the struggling students not doing as much work and the other students think it's not fair, or just the general discrepancy in the playing field, as it were. This allows students to pick their own project and nobody has to worry about, oh, well, they got an easier project. Well, they picked it. So choice boards are fantastic. I highly recommend them. And we have a exercise bank and a project bank that would lend itself to choice boards very easily. Um, Learning environment is sometimes more difficult, especially in a computer science class. If you're in a lab, you're kind of limited on your options for arranging your classroom. If you have laptops or Chromebooks, you have a little bit more freedom to move your desks around. Um, the learning environment should be inviting, and the students should be excited to be in your classroom and not intimidated or bored. Blank walls make students tired because there's nothing interesting going on, and it's just a big empty room. But you have to be careful not to put things that are too distracting on your walls, because the students will be more interested than what's on your walls than the course. So other ways that we can differentiate: the whole class options, flipped learning. Our platform actually is already set up to be flipped. Each lesson shows or is structured in a way that supports a flipped classroom. So the students do the front end work at home, and then that leaves the classroom time for direct instruction and individualized instruction. You can do self-paced. You can let the students that are more advanced work ahead so that they don't get bored and they don't stop working because they're frustrated waiting for everyone else to catch up. Unplugged lessons are really useful because sometimes you just need to get the kids off the computer, and I know it may seem weird to teach computer science offline and not on a computer, but there are a lot of concepts that unplugged activities work really well for. For your advanced students, you can have self-directed projects and extra challenges where it's essentially just in lieu of the work that's already been done, they can do a more difficult option. Instead of, if you trust the student to work on their own, you can give them the directions on the project and let them go while everybody else is working as a group. And we have extra challenges, and we have things built into our platform that can help us facilitate that. For remediation, you can do peer programming, which is pairing students up with peer programming. The way it usually works is we have what we call a driver and a navigator. The driver is the person that's actually typing the code. The navigator is the one that's telling them what to do. And then they switch roles back and forth. That allows students a different perspective. And when you're having to dictate what the code should say, you have to think about it differently than if you're just writing it out. And so the peer programming gives the students the opportunity to both write the code and explain the code. So graphic organizers, again, mapping out your code on a flow chart. You can even make the blocks on paper and have them assemble them offline. You can do small group debugging. There is a method that I actually like because the students kind of tend to get into it, called rubber duck debugging for your more introverted students, especially. They have a physical rubber duck that they talk to, and they talk out the problem. And you're not expecting a response, obviously, because it's an inanimate object, but it gives them a physical representation of talking it out. And you can get rubber ducks of all different types, in costumes and colors and everything, on Amazon for fairly cheap. And then I would always let my kids pick out their duck at the beginning of the year, and then they got to take their duck home with them at the end of the year. And they've kind of made a friendship with this rubber duck. And that's a common debugging tool for classrooms, and it's really fun for the kids, especially the younger kids. Ways that you can challenge advanced students. There are supplemental materials, and these are links to our materials. We have supplemental materials that students can work on. We have a problem bank where you can pull resources in and pull problems in from an existing resource, an existing collection of problems. You can create custom assignments and playlists, and I think we might have time to look at a little bit of that here in a second. So for your advanced students, again, we have extra challenges. I liked to use these challenges as assessments, and you can have the students pick the you can have the students pick the project they want to do. You can have them work through the different work through all of them, however you want to do it. You have complete control over that. So this is a good thing you can give to advanced students. And I have substituted these in assignments before. So if what the rest of the class is working on is not challenging my advanced students, I will actually trade out for that individual student, and they will do these extra challenges in lieu of the actual assignment that everybody else is doing. In exercise challenges, a lot of our assignments have a extra points, extra credit challenge. The wording varies from lesson to lesson, but it takes the lesson and has its bare bones. This is what we expect you to be able to do. If you want to take it further, if this is not challenging to you, you can add this element to your assignment. For example, your coding scheme needs to be able to represent every capital letter, A to Z, and the space character. For an extra challenge, include every lowercase letter, every digit 0 to 9, and the period character. And so everyone is doing the base. And if you have someone that gets through very quickly, they can challenge themselves to do the extra work. Our problem bank, you can search for problems that have been submitted by other users. You can narrow it down by the programming language, the type of programming. Is it an exercise? Is it an example, whatever, and filter it down to find projects and problems that you would like to implement into your curriculum. Robin is putting links to knowledge-based articles that are explain how these features of our platform work in the chat. For struggling students, they may need extra practice or scaffolding, and you can use supplemental materials. For some of my struggling students, I would reduce the assignments because you can control individual students' assignments, and I would go in. Now this is a pro feature, but I would go in and I would narrow down. And if the student's IEP said they had reduced assignments, and the activity had 4 exercises, that the rest of the class would do, I would cut that in half, and the student would only have to do 2. Sometimes I would let them choose, but that starts getting the grade book to look all a little funky. That just how you choose to do that is up to you. We have some supplemental practices that are available to give your struggling students a little bit more practice on you implementing these concepts that they may be struggling with. We have offline materials, and that the students can work on away from the computer that will help them out. And then, of course, as we looked at earlier, block coding. And here actually is an answer to the previous question. The languages compatible with blocks are Carol in JavaScript, HTML, and coding in art, music, and sports. And then we have intro to computer science in JavaScript, APCS principles in JavaScript, computing ideas, web design, and intro to programming with Carol. All right. We have about 10 minutes left, so I'm going to open this up to some questions. I think we have some in the Q&A.
Yeah, so we have a question. How do you handle grading when students work at such different levels? If a student picks a more challenging project and doesn't achieve the highest outcome, are they penalized? Or how about when a high achieving student chooses an easier project? Are they penalized? Just wondering how to keep students working at an appropriate level and keeping the grading fair.
Just my perspective of how I ran my classroom. That's really the best I can offer you is how I ran my classroom. My struggling students, the understanding was if you chose a more challenging assignment, the due date didn't change. The due date was the same for everyone. If they chose the more challenging assignment, it was something that they were taking the responsibility of being able to complete that challenge in the time allotted. If the advanced student was picking the easy assignment so they didn't have to work as hard, at first there would be no penalty for that. Like academically, I wouldn't penalize them. As the year would go on, and as you go through, you will learn how your students' levels and whatnot. Conversations and communication. Talk to your students that are not picking the appropriate assignments. If you're giving them choices and they're not choosing what is appropriate to their skill level, have a conversation with them. If you have a student that really wants to push themselves, but they're just not meeting that, encourage them to maybe drop it down a peg. If you have a student that is capable of more work, talk to them and trying to encourage them to do work that is on their level. My last ditch was take the choice away from them. I don't believe, this is just my personal belief, I don't believe in academic punishment for behaviors. And so I wouldn't punish them with their grade, but I would take the option away from them. If I have an advanced student that is not choosing is choosing easy assignments because they want to be lazy and not do the work, I will take that choice away from them and I will tell them this is the assignment you're going to do. You have not lived up to your responsibility of making the choice, so I'm going to make the choice for you. So I hope that helps. To sum that up, I communicate with my students and I'm open to adjusting, and it's a fluid method. And if the student is not going to participate in the nature of the assignment and the choice, then I will just take that choice away from them. So, debugging question. Is there a debugging feature in which you can set breakpoints and see variable values? I'm not exactly sure what you mean by that. I think I know what you mean. You can see a variable value by putting a print statement in. I've done that several times to make sure that my variable is printing out the way it's, or is being passed the way it is I'm intending it to be done. So anywhere that you need to test the variable value, you can just put a print statement. As far as setting a breakpoint, I'm honestly not sure. That's that's not anything I'm familiar with. I will be honest with you, and I apologize for my ignorance on that. If that is a feature we have, it's nothing I've come across in my classroom or in the few months I've been with the company. So I do apologize for not having a better answer to that. So my method of doing the variable value would just be a print statement where I needed to check the value. So uh we still have about 5 more minutes, but I want to get through these last slides with some important information. If you would like to become a CodeHS certified educator, we do have that program available. We have micro credentials available where you can prove your knowledge on a particular subject. We have a Facebook group for educators to work together. And then, of course, we're on social media. The webinar survey, if you have any comments, this data is very important to us. It's how we make these surveys work and to best serve our customers and our teachers. So please fill out the survey and let us know how we're doing. Again, the certificate of completion link, the survey link is in the chat. The certificate link is in the chat as well. And you must be logged into your CodeHS account to get your certificate of completion. We have a teacher trainer program. So if you or one of your colleagues is passionate about CodeHS and would like to work with other teachers and do things like we did today and lead a webinar, we have an application available until Friday, July 12th to be a member of our teacher trainer team. So if you are interested, please click the link in the chat and let us know, and we will get that process going. Lastly, some upcoming webinars we have are on the screen at codehs.com/freepd. You can find links to register for all of these upcoming webinars. We are halfway through the summer, so if there's any other last minute PD that you need to get before you go back to school, we've got some that are an hour, we got some that are about 90 minutes. So choose what works best for you. We have plenty coming throughout the rest of the summer. So you can always go to codehs.com/learn more if you are interested in bringing CodeHS to your district. And thank you for your attendance. We're pretty much out of time. So if you have any last minute questions, drop them in the chat and or put them in the Q&A, and we'll try to answer them in these last about minute and a half we have. But thank you. Enjoy the rest of your summer. And again, if anybody's in the path of the storm down south in Texas, please be safe.